Hypothesis test is just going to tell me whether I have correlation or I do not. So there are ones to test for positive correlation or negative correlation. We're only interested in whether there is correlation or not. And then from the actual R value itself, we can tell whether it's positive or negative. So we're going to use these two. And our null when we start has to be that we assume there's no correlation, that there's nothing that's actually relating these two to each other. The alternative every time is going to be that there is correlation. So if you reject the null, then we have that there is statistically significance in the correlation between the two. And notice we're using rho. It looks like a P, but it's actually the Greek letter rho, and it's saying that you're using that's what we use for the correlation of the population. And R is our value that represents the correlation for our sample. So we have those two things. And the reason that rho is equal to 0 is because 0 means there's no correlation. And then if it's not equal to 0, we have some sort of correlation in there. And I know we probably thought we were done with hypothesis testing, and we are getting close. But we do have this table to create our critical R values. So if we want to just create our R value and then get our critical values from here, we can use that to make a decision. Now notice we're only going to test when alpha is 0.05 or 0.01. The R values don't have a lot of leeway in them. We're kind of set with those. And I also want to point out, because in our chi-squared and t-distribution, they use degrees of freedom. R actually just use n. How many ordered pairs of data do you have? So when we're looking, we just need to bring n here and then our alpha to figure out what our critical values are. All right, so let's see if we get any significant correlation between these things. So our town country listed below are amounts of court fine revenue and salary paid to the town justice. Based on the data, that just tells you where it's from. All amounts are in thousands of dollars, and all the towns are in Dutchess County, New York. Is there sufficient evidence to conclude that there is a linear correlation between court income and justice salary? Based on the results, does it appear that justice might profit by levying larger fines? All right, so I'm going to create my hypothesis, which for the first one, every time we're going to say rho equals 0, or if you want to say no correlation, that's fine. And then my alternative is that rho does not equal 0 and there is a linear correlation. And they wanted to know if there is a linear correlation, so that's where my claim is. And I didn't put it, but I'm going to use alpha of 0.05 for this one. It has to either be 0.05 or 0.01. All right, so then, how many ordered pairs do we have? What's my n for this? Yes. So if I have 9 and I have 0.05, we can find our R critical value. So I'm going to call in my R alpha. I'm going to go to 9 on my table and over to 0.05. So my critical value is going to be 0.666. Then what I need to do is I need to find R. I need to either find it in my calculator using the two lists, or I can find it in StatKey, and I do have that data preloaded, so we can find it in a couple ways, but let's take a look by putting it in our list. So I'm going to put all of the court income in one list, and then the justice salary in another. So 65, 404. 1, 5, 6, 7, 2, 2, 5, 2, 1, 154. Yeah, I don't want to go incorrectly. 92, 57, 46. 56, 46, 61, 25, 26, and what's my last number? 18. And remember, these need to line up, so I missed something. Our two lists should be the same length. All right, and then what do we run for this to figure out what our R is? Calc and then 4, our Lin Reg. And we tell it our list 1 and our list 2. It might want them with just commas in between, either way. All right, and I'm going to get my R value. So we're going to get the 0.300. And if we were to try to, it's not a normal curve necessarily, but just because that's what we're used to. Our critical value is this 0.666, and our value is 0.3. So what decision would we make about this? We would fail to reject. Which means what? There is correlation? If I compared it though, my null hypothesis is what? That there's no correlation, and I did not reject that, right? So I can't say there's correlation no matter what that R is telling me. Because the R, like we saw with our picture above, can be influenced by a single data point. So we have to assume from this that there is not evidence to support the claim that court income and justice salaries are or have a linear correlation. You mean for R?
Yeah.
I don't know, we can see. So if we go and run the Lin Reg with list 2 first, Yep. At least for R. It will affect your A and B, but your R is going to be the same.
So you don't really have to be concerned about which variables you come in.
Not for R necessarily, but we do want to know for the equation. And since they're telling me that the court's income and justice salary, well, we would assume that we're looking at the justice salary being dependent on that court income. So we would say that this is our X and this is our Y when we get to the equation part of it. Yes?
If you said in the have linear correlation, what if you said they just don't have correlation? They're just saying linear, like on the test.
There's no correlation?
Yeah.
That's fine.
That's fine.
Yeah. Other questions? Getting a different R? Well, let's see. I might have typed something wrong. I was having issues adding my data in, so it's definitely... nothing.
It's your second one, your third one.
Oh, it's missing the 6.
Okay.
So that might change the results then. Let's make sure I did all the rest of them right. I'm having an issue with typing today. Alright, let's try that. I like that you guys didn't say anything and you let me finish the whole thing. Alright. That might change our conclusion too. Alright, that's a lot different. So 0.8643, what is that going to do? There's no more reject, so we're moving this. It's going to be out here further at 0.8643. And we would reject. Reject the null, and now what does that do down lower? It doesn't have to change a whole lot. All I have to do is get rid of the insufficient and change it to sufficient evidence to support the claim that the court income and justice salary are linearly correlated. Which is probably not good if you're going in for a fine. So what do we think? If it does have a linear correlation, the other question here was, based on this, do the justice profit from levying larger fines? Yeah, they do. All right, questions on that? Can we all find our R alpha and get an R if we type the correct data in? Yes? All right, so I want to try the next one, and we're going to do it just a little bit different because there is actually something to help us. So a campus crime listed below are the numbers of enrolled students in thousands and the number of burglaries for a randomly selected large college in recent years. Based on the data from New York Times, is there sufficient evidence to conclude that there is a linear correlation between enrollment and burglaries? Do the results change if the actual amounts are listed? So if you actually put the zeros rather than just the 32, 31. So we'll look at that in a minute. So what's my null and alternative? Well, the null is that your population correlation is 0. And the alternative is that it's not 0 because we have no correlation or there is correlation. And I'm going to give us alpha of 0.05 because I forgot to type it in again. This time I want to enter the data, and we can find our R, or we're going to find a p-value again. So let's go ahead and enter our data. This time I'll try to enter it correctly, and then we won't come out with the wrong answer. And we got 801, 800, or 103, 86, 57, 32. Nope, that didn't go in right. 57, 32, 131, 157, 20. That's my last two numbers, 27 and 161. That doesn't line up. What happened? I don't need the 30 and 40. Let me get rid of those. All right. So, did everyone get your data in? All right. Now, I actually want us to go over to the testing area. And down towards the bottom, where the ANOVA is a Lin Reg T-Test, because this is data. So it's going to be a sample, so it's going to be a t-test, but it's going to do my linear regression for me. And know that I'm testing for correlation. So in here, it's going to ask you, what's your X list, what's your Y list, and we want to know what we're testing. Frequency is always 1, and we're doing a not equals to test, because we're testing that there is correlation or not correlation. They didn't ask me about a positive or negative correlation. And then I don't need to put anything in the reg equation either. I just need to calculate. Did everyone find the screen? Yeah? All right, so let's see what it gives us. So now it's going to give me a t-test statistic, which we could go to our t-table and get a critical value for. And it gives me my p-value. So I can also just get my p-value from here and compare it to alpha. And I also want to note that if I go down, you still get r and r squared. So we can still figure out what our r is, and we can still figure out actually our equation when we get there. So we're getting some good stuff. So I'm going to take the r, the 0.5613, so that we have it. And then I want my p-value. And my calculator decides to go back. So my p-value is 0.0913. And if my alpha is 0.05, am I less than or greater than? So what would we do? And everybody agrees with my R this time? Okay. So we're going to fail to reject, even though that R is not that bad, right? It's showing me a moderate correlation based on our standards. But this is telling me there's no correlation between enrollment and burglaries, which we wouldn't really assume that there is, would we? Unless we think that all students are criminals. Not necessarily. The more people maybe, but not just because they're students. So we wouldn't really expect to find that just because we have more students, we're going to have more burglaries. At least we wouldn't think there's a super strong correlation there. And in this test tells me that there's no correlation at all. So, did they ask me? They're saying there is a linear correlation, so their claim was in the alternative. So there is insufficient evidence to support the claim that enrollment in burglaries have a linear correlation. Do we think that this would change if we use the actual 32,000, 31,000? Mm-hmm. The intercept would change, but it wouldn't change my slope. So the numbers might be bigger because we're putting bigger numbers in, but overall it's not going to change my R and the conclusion of my p-value. Those are going to be the same regardless. Really all it does is change the labeling on your axes for a scatter plot. This is also a nice way because if I don't want to make a scatter plot or I don't want to look at a scatter plot, I can tell whether my R is accurate or not without having to look and see whether my R is telling me something inaccurate, like in this example where we had all of our data grouped together but one point and we got a very positive R, but in fact our R should have been negative. So this kind of gives me a better estimate of whether I should trust that R or not, even without some kind of plot. Questions on it? No. All right. I have one more for us to try. Does anybody need that page before I go down? All right. So we're back to our cricket chirps, and it's a classic approach of correlation involving an association between temperature and the number of times cricket chirp in a minute. Listed below are the number of chirps in a minute corresponding to the temperature. Is there sufficient evidence to conclude that there is a linear correlation between the number of chirps in a minute and temperature? So we have, they didn't label it that way, but we've got our X and our Y because the temperature is what's affecting our amount of chirps. It's slightly different data than we had in our other example, but not that different. My null hypothesis is still that rho equals 0. Because the population correlation coefficient is equal to 0, so there's no correlation. Or the alternative is that there is correlation. So let's see what we're going to get for this. I want the R and the p-value. And just to change it up, because I forgot to type one in, we're going to use alpha equal to 0.01. On the exam, I will have it typed in so that if you need an alpha, it'll be given. I just forgot when typing this that I didn't include one. You guys probably got the data entered faster than me, so if you've got your values, just let me know.
You got
Yeah.
0.0045. That's not number.
All right. And then how about the R?
0.8736.
All right. Does anyone agree?
Yes.
So even with choosing the stronger alpha to be more critical, I'm still significantly less than it. So what does that tell me? Reject. So we're going to reject the null, which means
Sufficient.
There is sufficient, or there is enough. To support the claim that temperature and chirps are linearly correlated. Questions on that? Oops. It won't go away. I'm trying to stop my video. I can't stop it. There was a way to do it. There it is at our equation. So a linear model to predict the price of a particular car for its mileage was calculated from a sample of 38 cars during the week of January 2011. The results of the regression equation and correlation coefficient are given. So, well, actually, they didn't give us our correlation coefficient, but we have our regression equation. So if y equals this equation, and notice that this number is my b naught that we had above, and this 0.0151 is my b1, just so we can keep track of the pieces. We want to know what's the correct interpretation for the slope. So we're talking about the predicting the price for the miles on the car. So what does that make y, and what does that make x? Is y the price or the miles? Y is the price and x is the miles. So we want to keep that in mind as we're going through. So for every $1 increase in cars, there is a 24,356.15 mile increase in the car mileage. Does that sound accurate? That doesn't make any sense. All right. For every 1 mile increase in the car mileage, there is a $0.0151 increase in the car price. All right. For every 1 mile increase in car mileage, there is a $0.0151 decrease in the car price. That sounds more right. All right, so let's put a star there. For every $1 increase in price, there is a $0.0151 mile decrease in car mileage. We're not increasing the car price 1 unit, so it kind of looks like we're looking at C. Why are we choosing C over B? You're not going to increase the price of the car with more miles. And notice we have a negative with our slope. So the negative tells me that I'm decreasing the price as I go more miles. So it can't be the increase. This one had them reversed and that one had them reversed. So it left me only with the option of C. But it kind of gives me an idea of what I should look for. So we should look for which one is the slope, and is that slope positive or negative, because that's going to tell me whether I'm increasing or decreasing. And then make sure that it's actually telling you about the correct thing increasing or decreasing. So we wanted the price to be decreasing rather than the miles. Questions on that? All right, as a particular cars for Kelly Blue Book price was $24,000 and it had 50,000 miles. What is the residual for this car using the model above? So how can I figure out what the residual should be? Use the X. What's X?
24.
Well, 24 is money. So 50,000 is my X. Y is this 24,000. And a residual means we need a predicted amount. So what should I do with the 50,000? Plug it into the equation for x. So I'm going to say my y hat, which is 24,356.15 minus the 0.0151 times the 50,000. And I want to see what we would have predicted for a car having 50,000 miles. 23,601.15. So we would have predicted $23,601.15. They're saying that it was worth 24,000. Probably did some rounding. So if I want to find the residual, what should I subtract from what? So which one goes first? 24,000 minus the 23,601.15. And what does that give me? .8. All right, and just a reminder, these are all in dollars. So what would we have done with this? Did we overpredict or underpredict? We underpredicted. Any questions on that? I really want to spell care instead of car. Don't know. I kept spelling care instead of car. Maybe I care more. Questions? All right, let's take a look at the next one. So a study was conducted to investigate the relationship between total team salary, X, and it's in millions, in the NFL, and the number of wins, Y, out of a 16 regular season game. The following regression equation was obtained. So give a one-sentence interpretation of the slope for the regression. So what would you tell me? Well, first off, what is the slope of this? Which number is the slope? That's my 0.062. All right, and what would you tell me about it? It's positive. So we're going to have some kind of increase. So if we went back to our little piece up here, we would start with for each $1, is that my units for X? Or I guess millions of dollars. So for each $1 million increase in our salary. Now we can go back and say our Y is going to be increased. And Y is talking about the wins. So our wins will increase and we want to go back because it says we want to increase by the slope and the units of our Y. So we're going to increase by 0.067 262 wins. I don't know. It's a good question. It's a good question. It maybe is an accurate model. Maybe we need to test it for the real correlation. I can tell you based on the 49ers, they're not paying them enough if they want to win. If this is true. All right. Questions on that? Yeah. I don't actually really have a team. If I had to pick one, I am from Northern California, so. And that's who my dad always, no, not really. No, and they're going to Vegas, so nobody cares about them. No. I do, but that's significantly increased since I met my husband. All right, any questions on interpreting the slope? No. So if a team spent $60 million on salaries, if the residual for the team was calculated to be negative 1.503, what is the true number of games won? Any idea how we can figure that out? Okay, so we can plug it in. Y hat equals 1.783 plus 0.062 times the 60 million. So what does that give us? Five. Is it that small? That makes sense. That's true. All right, so that's the amount of games we predict them to win. So we could round it to 6 because I guess they could have a tie. I guess there could be half of a win. But if that's what we predict to happen, and then they told me the residual, how can I figure out the amount that they actually won? Y minus y hat equals the residual. So we have a couple of pieces of information here. We have the residual, which is negative 1.503. We don't know what y is, but we just predicted to be 5.503. Or was it 60? Okay.
5, 6.
0? Well, because my 0 looks like a 6. All right, so then if we move that 5 to the other side, how many games did they win? So y equals 4.06, or basically 4 games. Did the Chargers even do that well? Sometimes I'm not sure. They did do better, that's true.